Okay, so now we're dealing with a change in the objective function coefficient. So change in objective coefficient, and let's say example, let's say that the 1, the implied 1 here, is going to 1 plus delta. So the question is, how is that changed? We're going to have 1 plus delta, so we're going to have this 1 is going to go to 1 plus delta. Well, it means that we're going to have x1 plus 2x2 plus delta x1. And so we get x1 plus 2x2 plus delta x1. Now, here comes the maybe bitter pill, is that when we go through the iterations to arrive at the final equations, the z coefficients never mix in to derive at x2 and x1. When we go derive at x2 or x1, we're always combining x3 and x4. These are being combined in different ways, going through iterations. Different variables come in, different variables go out. The z equation is always a consequence, the z equation at every iteration is going to carry with it a little appendage of delta x1, and that little appendage of delta x1 is going to carry right through to the end, where this is going to end up with a delta x1. So it'll be exactly the same thing, except this delta x1 is just going to be carried through from iteration to iteration. Well, x1 is a basic variable, so we're going to have to solve. So it's 23 halves minus a half x3 minus a half x4 plus delta, and x1 has to be replaced with, well, maybe put this on a separate line, plus delta 5 halves plus 1 half x3 minus 3 halves x4. And now we simplify, and we have, this is 23 halves plus 5 halves delta, and we're going to have minus a half minus a half delta x3, and minus a half plus 3 halves delta x4. So we're just gathering terms in terms of x3 and x4. Well, what we see right away is that as delta is increased or decreased, if we get more revenue or per profit per chair than $1, if we get more, then we're going to make 5 halves more profit. That's one immediate result, and the other result is that we cannot, for this solution to remain optimal, we have to have that well, perhaps I should stick to my convention here. Pardon me. Otherwise I won't have anything to highlight with. This is going to go that z is equal to, this is going to be such that half minus a half delta has to be greater or equal to 0. Okay, for this to be optimal, if this goes negative, then we have an increase in the objective function, and I would make x3 basic. the same thing with the other expression. So that has to be, and also a half plus 3/2 delta has to remain greater than 0 for optimality. And these two then imply that this implies that delta is less than 1. And this implies that delta is greater than -3. Okay. Sorry, no, not -3. -1/3. We have that 1 plus 3 delta is greater than 0. So delta is greater than -1/3. And then this is the solution, that this is the conclusion that we have. So number one, it goes up by 5/2, so we can tell right away. And the other one is that the deltas cannot stay outside of the range shown. Now, it's very important to note also that the solution remains unchanged for a delta. So that nothing changes. So I think we need to look at this again in the graphical sense to see what is happening.